Hello and welcome back. It's time to move beyond primitive data types and start talking about classes and objects. So this is the beginning of the object-oriented part of the class, and everything after this we will be doing object-oriented programming. So let's start talking about classes and objects. So the first thing to know that is a class is a data type, and people will call this an abstract data type or a user-defined data type, depending on which academic you're talking to. And an object is an instance of a class. So you have the class is the definition, and the object is one of those things. You can think of this as the same as an int is the data type, and counter is the variable of that data type. So we're going to define our own data types and make instances of that data type. There can be as many objects created from one class as you need, just as there can be as many ints, variables created as you need. Some people like to think of the class as the blueprint, and the objects that are created from it are the things that are built from the blueprint. So all of this is fundamentally easy. It's conceptually very easy, and when you start typing it, if you type along with me, you'll find that it's easy in practice as well. This is designed in. If this were difficult, it wouldn't work. So the reason that we have object-oriented programming being so successful is because it makes sense. And you don't know what that means yet, but you're going to very soon. Let's just go immediately into Eclipse and build a class, look at the conventions, and start using them. So get your Eclipse open and do this along with me. If you do, you'll have different parts of your brain firing neurons, and you'll learn it more easily than if you just sit there and watch passively. So here's our usual starting point. We have a class with a main method in it, and we're going to start by saying, well, what if I wanted to be computing with dates? I want to have my birthday in a variable. How would I declare a variable that would store my birthday? Well, I might say I need to declare 3 ints, a month, a day, and a year. And now I also want to have a variable that represents my anniversary. So I'm going to type another one. Well, what variable names will I use? Anniversary day. I can't spell very well. Anniversary month. And so on. Now, if I wanted to pass my birthday to a method, I would have to pass 3 variables. And that doesn't recognize that month, day, and year are one thing. What I would want to do is to pass around one variable that represents the birthday. And you might be guessing already that that would be an object. So this is the way we don't want to do it. And especially if it gets complicated, if one thing has a dozen component parts, how would we pass that around using primitives? We would have to declare a dozen variables and pass a dozen parameters to a method so that we could get the information into the method. And that's just not workable. And we're going to instead define a new data type to pass around things, and I'm going to name this one date. So I want to have date birthday, and I want that variable to store the month, the day, and the year that represents that one thing. Well, it doesn't compile because we don't have a data type called birthday, and that's what we're going to define. I'm sorry, we don't have a data type called date. This is the data type, and this is the variable. So I'm going to go back to new and say class, and I'm going to define a class called date. Don't put a public static void main in it, just leave everything else the way it is. And now we have another file in our project called date. It starts with a capital D. All classes will start with a capital letter. And look what happened already. This compiles. So this is the smallest possible class. It doesn't do anything and it's of no use, but there is indeed a new data type created now called date with a capital D. So this is a valid declaration of one of those things. But it doesn't do anything, so let's go and make it more interesting. Let's start off by saying, what does a date have in it? And if we say has out loud, and it makes sense, then it's right. So let's try it. A date has a month. A date has a day. A date has a year. And if that makes sense, then it's right. So these are called instance variables. Instance. So every instance of this class has one of these things. Already we've done something useful. This compiles, and we can use it just the way it is by saying new date. And that's a method call. We'll explain that a little bit more later. But I do now have an object of type date, and it does have in it a month, a day, and a year. We can actually use it. We can say birthday dot and see what pops up. Well, day, month, and year pop up, and some other stuff that you don't know why it's in there. That will take a few more videos to go, but for now just understand that the component parts of the thing that you just made are in there, and they're int, and they belong in the date class. So I could say birthday.month gets 11, birthday.day gets 16, birthday.year, how old do I want to be? 1980. People born 1980 and later are the millennial generation. You never know what you're going to learn in here, do you? The millennial generation. It's not me. I'm a baby boomer. Okay, there's something more realistic. But now we have something that does something useful. Not too much useful, but it associates these three things together as one thing. If you're a C programmer, you might recognize that we defined the equivalent of what you can do in C in a struct. But that's not important. We're just beginning making our own data types. And it was really, really easy. What is the data type of birthday's month? It's an int. What is the data type of birthday? It's a date, capital D. So you can use those three ints as component parts of birthday like any other int. And if you need another one, you can make a new one. So now I have a new object of type anniversary, which is never used. That's why that yellow warning is there. So these are the objects, birthday and anniversary, and we say those are objects of type date. And date is the name of the class. So I'm just going to throw this away to make things neater. So we've done something already very significant. We have classes, we have a class anyway, and we have objects that were created from that class. So everything from now on is to elaborate on that process to make the classes more useful. And it's very conventional. So you don't make up stuff that you want to do, at least not for these first few weeks. You follow the convention exactly. And it becomes kind of a typing exercise if you know what all the conventions are. And the books that are published on this often don't make it as clear as they could that this is just the way that you do it by convention. And don't try crazy stuff to make it do what you want it to do. Just follow the convention until you get really used to how this happens. For example, always uppercase letters, because when I'm reading your code, I need to know the difference between your objects and your classes. It's possible you could define a class called birthday and I wouldn't know the difference if you didn't use the conventional capitalization. Okay, so the first thing that we're going to do is change the birthday month to 16. No, I already used 16. Let's use 19. Well, what's wrong with that? There is no month 19, but this code still compiles and runs, right? Doesn't print out anything, but it did run with no errors. So we don't want there to be a month 19. The author of this class didn't do a very good job because they allowed the month variable to become something that it shouldn't become. In fact, a worse convention was broken here. The user of the class was given access to the variables directly, and this is kind of forbidden. So what we do to prevent this direct access to the variables is we go into the class and we make these private. So a private variable is a variable that can only be seen inside of the class. I can't type today. Okay. So these private variables are only accessible inside of this class. That means that this code will not compile anymore, and it doesn't. So I'm going to comment that out for a second so that we always have working code. But now we have a class that's completely useless. It has stuff in it that we can't get to. And we have to make some methods that would allow us, the user of this class, to get to the data. So I'm going to define a method, a public, not static, a void method called getMonth with no parameters. And the naming convention here is strict. You have to start it with get, and it has to name the instance variable with a capital letter. And this is called an accessor method. Some people call them getters. It's a very simple method. It says return month. Oh, I made it void by mistake. My mistake. It has to be an int. So we're returning one of the instance variables. So these instance variables that are declared here are declared in the scope of the class. That means that they're available throughout the whole class, including in the methods that are defined inside of the class. So an accessor method almost always is just this simple. You declare a way for the user to retrieve the value that's in that variable. And now we need a way for the user of this class to change the month variable. So I'm going to make a public void this time, setMonth, and I'm going to break the rules and make a one-letter variable name. And I'm going to put month gets m. This is called a mutator method, or a setter, like an Irish setter. Okay, that was funny. Never mind. Okay, so we've got an accessor and a mutator, and we should make one of those for each of the instance variables. So that's 6 methods altogether. Now let's go back here. Be sure you save this date class each time, because when you go back and forth between files, this file wouldn't recognize the changes that you'd made in the other one until you do the save on the other file. So we're going to say birthday dot and see what pops up this time. Oh, let's see. Here's a set month method, and here's a get month method. Let's call set month and set it to 11. And then let's do a system out print line, get month. So I'm going to retrieve the month, which is an int, from the object birthday, and just spit it out on the console to make sure that this is working for us. And it is. It outputs 11. Okay, the dot operator always follows the name of an object, and I want you to read this as ''s. So that would be birthday's month, birthday's year, birthday's set month. It's an ownership characteristic. Birthday owns this method called setMonth. Birthday owns this method called getMonth. So birthday's getMonth. Okay, that's a big step. We have a mutator and an accessor for this variable. But what happened here? Our whole deal for making those private was that you couldn't set the object to an invalid state, but we haven't fixed that problem. You can still set it to month 19. So let's go and fix that. In the setMonth method, let's check the value that was passed in. And we'll say if m is greater than or equal to 1 and m is less than or equal to 12, then we'll allow that variable to be set to the value that was passed in. So now we have sort of some protection on the instance variable to protect it from being set to an invalid value. When we run this one now, it prints out 0. But if we set the month to 11 and run that one, it prints out 11. So the setMonth method is not only allowing us to change the instance variable, but protecting it from allowing the object to go into an invalid state. So as an exercise for you, I want you to go and make a get year, get day, and a set year, set day method, and add those to your class using the exact same pattern. The getters always have a non-void return type, and the the dog says hello. And the mutators always have a void data type. So far, so good. Okay, you let me call a method here without saying anything. Well, you could hardly say anything because you're watching a video. But I called a method here which doesn't seem to exist. This is called a constructor method. A constructor method constructs the object from the class definition. And this is not a good constructor. It's the one that Java gives you. So every class has a constructor method. If you don't put one in, Java puts one there for you that has no parameters. But what I might like to do instead of this is I might like to set the state of the object, and the phone rings. Hang on. So this is not a good constructor. It's the default one that Java gives you if you don't put one in your class. So all Java classes have a constructor method. If you don't put one there, Java will put one there for you. So we're going to put one in here of our own, which is more useful. Now watch this. It's going to be public. That means it's available outside of this class. And a constructor method doesn't have a return type. And the name of the class is always the same. Sorry, the name of the method is the same as the name of the class. So this is a very specific kind of a method. This is a very specific kind of a method in Java. It's the only method in all of Java that starts with a capital letter. It's the only method in all of Java that doesn't have a return type. And our objective here is to allow the user to set the instance variables to an initial value. And I'm breaking my rule by using one-letter variable names. We're going to fix that later. Month gets M, day gets D, year gets Y. So now when we call the constructor, we are able to pass in the month, the day, and the year to create the initial state of the object. So I'm going to save that and go back over here and find out that this doesn't compile anymore. Well, when you put a constructor method in your class, Java takes theirs back. So this method that used to be there, even though we couldn't see it, is no longer there. So now we're going to put in the parameters that would match the constructor that we just created. What is my anniversary? I'm in big trouble if I don't get this right, aren't I? Okay. So now, send cards and letters. So now we have objects that were created including the value of the instance variables at the time we called the constructor method. It might be useful to notice here that when we don't set the instance variables to something, Java puts 0 in them. Do you remember the last time when we tried to set month to an invalid value and we printed out the month? It didn't give us an error message, it gave us 0. When you create an object, the memory for that object is created dynamically. It's allocated dynamically, and all of the instance variables are initialized. So you never get that error message that you have declared a variable but you haven't put anything in it, so you can't use it yet. So the instance variables in an object are always initialized, even if you don't put something in them. Okay, so what do we have so far? We have a constructor method, we have an accessor and a mutator method for each of the instance variables. And we're going to add one more thing to this class. I don't want these videos to get too long. There are a few more things that we could do, but we're going to get you started with here are the essential things that everybody does the same way. So we're going to add one more thing, and it will be a toString method. So the toString method returns a string, and it's always called toString, and it never has any parameters. So this is the way that you have to do it, and you can declare a result variable and then return the result, and then make it a fill-in-the-blank problem. So the purpose of the the purpose of the toString method is to return a string that represents the object that you have. So how would we like the date to be represented as a string? Let's concatenate together the month and then a / and the day and a / and the year into one string object and return that to the caller. So now we have a way of converting our object into a string object, and it's done in the standard way. So when you're creating your Java classes, it is expected that you will have one of these toString methods, and it is expected that all of the instance variable values will be in that string. So I'm going to save that, go back to this one, and I'm going to print out birthday dot toString. So if we run this and we print out birthday's toString, we get this result. So a nice textual representation of the object that we have. And the toString method is a standard way of turning your object into a string. So magically, if you pass an object to the println method, it will do the same thing. It will call your toString method for us. So now what can we do with objects? We can print them out, and they will print out in a way that makes sense for that particular object because we put the toString method in there as we were expected to. So I use the word magically, and people don't like that, but I'm not going to tell you exactly how that happened until a couple more videos. So for now, you can call the toString method explicitly if you want to, but you don't have to. When you're printing out the object, you can just say print this object, and it will print out what the toString method returns. Okay, let's go back and look at the name of the class is a noun. It's a thing. The instance variables are using a has-a relationship. A date has a month, a date has a day, and so on. A constructor method that allows the caller to set the initial value of the variables to a specific value. An accessor and a mutator for each of the instance variables, and a toString method that returns a string object representation of the object that we're working with. Instance variables are private by convention so that we can protect their values. Didn't do a very good job of protecting their values. We protected month from being outside of that range, but we allowed the user to set the initial state of the object to something that's invalid. We'll fix that later. So we're getting there. What we have here, just in this one page, is a huge chunk of object-oriented programming. If you find this easy and you get past typing this in and seeing that it seems to make sense, then you've made a lot of progress in object-oriented programming. So here's the summary for this video of how to define a class. So you make a new file, and the name of the file must match the name of the class. So this code will be in a file called date.java, and we declare instance variables. I only put one in here so I'd have room for the whole summary. The instance variables are private by convention so that they can't be used outside of this class. They can't be used directly outside of this class. The constructor method is a strange method because it has no return type and it has a capital letter. It must match the name of the class. Typically, it will have as many parameters as there are instance variables so that the user can set the initial state of the object when they construct it. So when someone calls this constructor method, they now have the ability to put something into the instance variables. Mutators and accessors. Because we made the instance variables private, we need a way for the user to get at the data. So we make public methods that are available outside of this class that allow the user to get and set the component parts of the object. And the toString method returns a string representation of the object. And all of these things are very strong conventions in Java, and if you say, well, I don't like to call my method setMonth, I want to call it something else, you could, but no one will work with you. So we have to follow these conventions because we're expected to, and it really does make it much easier to read everybody else's code because they're all doing it the same way we are. So this is a big start for us, and we'll go on from here to add some more things into the classes and just increase the complexity little by little so that it seems very simple as we go through creating these classes. I'll see you in the next video.